Philip, go for it, sir.
All right, thank you. I'll share my screen. Can you hear me?
We can hear you and see your screen.
Awesome. All right. So it's kind of complementary to the Graviflyer because it's the whole astrophysics theory behind, around the Graviflyer that basically explaining that gravity is a particle. I'm saying that the universe is 338 times the mass of the visible universe. So it's the real universe is much bigger than we think. Part of Einstein's relativity is right. A big part of it is wrong. Newtonian physics is kind of incomplete. I debated the theory for 10 years on CosmoQuest and International Skeptics, and now I propose an experiment aboard the International Space Station to prove that special relativity is wrong, and my theory is right. So it's approved, but I just need to pay for it. So 500K. So I'm doing a crowdfunding campaign for it. And at the end of my theory, I'll let you know a little thought experiment. I'll leave you on a thought experiment that's gonna twist your mind a little bit. I could say it ahead of time, but I prefer to say it at the end. So this is my manuscript right here. It can be found on fornars.com. I have the hypothesis here. I can't call them postulates, so I call them hypothesis. I'm basically saying that a co-moving framework moves coherently with the source of the strongest gravitational potential. You have a parent framework. I'm basically saying that gravity is a superimposed force of basically multiple gravitational layers, and the frame of reference spins along with the planet or the black hole or whatever, because there's no absolute framework in the universe, and I'll let you know why at the end of the presentation with my little thought experiment. Also, I'm saying also the kinetic energy. We all know the kinetic energy, but I'm basically saying there's just time contraction, time dilation. There's no mass increase. There's no length contraction. And I explained the light bending, the perihelion precession, the galactic rotation curve, the expansion of the universe without dark energy. I explained pretty much everything, and the galactic rotation curve without dark matter as well, because the frame is rotating along with it. All right. Hello? Okay, sorry.
Oh, sorry. No, sorry, I was muted. Phil, we just had an interruption there. Go for it, sir. And then we can do some questions. I think Alex had a question, but we'll come back to that.
Thank you.
I'm sorry. My apologies. I didn't have it set up for presenting. So go ahead, sir.
Okay. So here I'm saying I'm basically explaining the gravitational time dilation. I'm saying that I'm basically translating general relativity into simple algebra that I'm extending into calculus later on. Here I'm talking about the kinetic time dilation factor that is a little bit different than the special relativity time dilation factor by a small factor. Here I'm basically talking about the inside the sphere time dilation. Nothing special here. I'm just presenting all the mathematics. The outside the sphere, and here, yeah. So the interesting part is pretty much the gravitational time dilation here. I'm explaining everything. I'm talking about the bending of light in a gravitational field without length contraction, space, curvature, space-time, and all that. I'm saying that I'm just explaining everything with time contraction and time dilation. The perihelion shift right here. So I'm doing all the maths. I'm also talking about the GPS and the time dilation cancellation altitude that can be calculated. Here there's a little discrepancy with general relativity. So that's an experiment, another experiment that can be done to prove that general relativity is wrong, but might be hard to test. It's just easier to test aboard the International Space Station. Here I'm talking about the gravitational redshift with the famous, you know, I'm just recalculating the gravitational redshift, and I'm saying that you know, there's going to be a discrepancy of the of finite theory with general relativity. Bon, the cosmological implications, the fun part. I'm saying also that if we change the if we create a tunnel, the three main things that we can make use of with this theory is the fact that we can time travel into the future very easily, but that's just by increasing the gravitational potential in a tube or something like that. It's like perfect cryonics. So you freeze a body, the body will time travel into the future, but you cannot time travel into the past. So that's why the video that you just saw before, it's impossible, because you cannot time travel into the past. Time is not a dimension, it's an absolute. It can be contracted, dilated, but it cannot be negated. So here I'm calculating that the position of the moon is 7 meters farther away than what we think it is, 7.36 meters. The parameters of the invisible universe, I'm saying here I'm calculating the mass of the invisible universe, which is 7.33 times 10 to the 55 kilograms, which is 100 times more massive than the visible universe. So the real universe is a lot more massive than we think, a lot bigger than what we see. And this is based on the light bending only. I'm basically solving the light bending. The galactic rotation curve, I'm calculating the galactic rotation curve here without dark matter. I'm saying that because the black hole or the galaxy is rotating, the frame of reference is rotating along with it. So that's why we see a different, it affects the rotation curve. So that's why we see this, we see a different rotation curve for very massive objects. I'll confirm this at the end of the presentation with a little thought experiment. Here I'm explaining the expansion of the universe without dark energy. And here is my experiment proposal. I'm suggesting to send a wavelength meter aboard the International Space Station, because the International Space Station is fast enough to detect a different wavelength for a laser going at 90 degrees in each directions. So I'm doing the calculation right there with a special high precision wavelength meter that exists already. It's possible to calculate this. And the thought experiment I wanted to talk about is, just imagine if you have an empty universe with a lonely star in it. Okay, there's no other thing than the lonely star, and it spins. The star spins. Will the star eject plasma? That's my question. So yeah, so that's my that was my presentation. Thank you. I'm not prepared. Sorry about that, but that was the last minute. But thanks for your time, and it's very complementary to the Graviflyer, because I'm saying gravity is a particle, and we can manipulate it. So that's why I'm not surprised that the Graviflyer is working. So yeah, thanks for your time. I appreciate.
Yeah, well, Phil, thank you for presenting. Thank you for going over this with us. So, and what I will do is, I will take this and I will block this out so that it's its own separate little video in the series. But everybody, you know what we should do, since he presented on that, let's give Phil a hand.
Mm-hmm.
I know later in the evening we get a little sloppy with that, and I should apologize. I try to be respectful and supportive of everyone, and sometimes, especially today, I feel like I'm just mistake after mistake here.